Good afternoon, everyone. Welcome to Nature Live Online. I'm Alison. I'm your host for today. Now, if you're a regular viewer, welcome back. It's great to have you. But if you're new to Nature Live, we're an event where we give you a chance to meet some of the scientific staff that work behind the scenes at the Natural History Museum in London. Now, the museum has now opened its doors to the public, and we put lots of measures in place to ensure you have a brilliant and safe visit. But not everyone can make it to the museum. So we are bringing our science and our scientists direct to you at home. Now, today I am very excited to be joined by one of our researchers, Zach. He has been looking at signs of water on Mars. It's a fascinating topic, so very, very interested. I've got lots of questions for Zach, but as usual, we'd love to hear from you, our audience. This is your chance to ask your questions too. So please don't be shy. If you have any questions at any point, pop them in the comments. We'll do our very best to answer as many of your questions as well. But let's meet our speaker for today. Zach, are you there?
Hi, Alison. How are you?
I'm great. Thank you, Zach. Thank you so much for joining us today. I am really looking forward to this one. This is a really, really interesting topic. Obviously, you know that.
It's one of my favorites, obviously, yeah.
Now, Zach, let's start first of all by finding out what it is you do at the museum.
Yeah, so I'm a PhD researcher at the museum. My background is originally in geology, but here at the museum, I'm now studying the surface of Mars. So instead of going out to the site like a field geologist, I study images of the surface of Mars and piece those together about what I know about the geology, and I'm trying to learn about ancient oceans and lakes on the surface.
And did you always have an interest in space? How did you come to work on Mars?
Yeah, I mean, I think most kids have some interest in space, right? So that and dinosaurs, it's it's a good combo. But yeah, I mean, from a very young age, I remember the first rover missions and things like that, and being really excited. I didn't really see it as an option for me to get involved until after I had done my geology degree, and then uh, I learned that actually I've studied all the geology of Earth, but you can use a lot of the same concepts to study geology of any rocky planet or rocky moon. So it was a great way for me to get involved in the subject.
Right, there's geology all over the solar system. I wish I'd made that connection when I was at school studying geography.
Yeah.
Now, Zach, you have an interest in astronomy as well, don't you? You've been doing some astronomy from home during lockdown, particularly.
Yeah, it's nice. I mean, it's I can't do my scientific research from my back garden, but it's amazing how much you can see just using a set of binoculars, or even just going outside and looking and taking pictures with your phone. This image is something I took over the course of about a month. It's of the same part of the sky. I took a picture every night at the exact same time, and you can see there's kind of a little squiggly line at the bottom of dots, and that's the position of Venus was changing from night to night as the orbits of the two planets passed each other. So there's things, if you've got a little patience, you've even got a little bit of time, just every evening go outside and have a look at where the moon is and where the stars are, and it's amazing how much you realize changes night to night.
Absolutely. I remember Venus was the first planet I ever saw through an amateur telescope, and I just remember that feeling of excitement. It's not even the most interesting planet surface, but it's a whole other world, and it's just fantastic. And
Yeah,
what about Mars? Because we can see Mars without a telescope at the moment. Is that right?
yeah, absolutely. So the brightness of Mars changes throughout the year, and because of the way the two planets orbit the sun, they're only really close to each other once every 2 years for a few months. And we're actually in that period right now. So it's the perfect time to go outside and look at Mars. And if you want to, it's just look to the east, about around where the sun comes up in the morning. But if you look that way in the evening, right after sunset, you should be able to see Mars rising up in the sky.
And if we were to look at Mars through at like an amateur telescope, what would we see? What sorts of features?
Yeah, so I mean, it's so bright now, you really can't miss it in the sky because it's as close to the Earth almost as it ever gets. Uh, but if you have a telescope or even a set of binoculars, you might be able to see some of the features on the surface. So this image is actually taken with about an 8-inch telescope, and it's you can see some features saying there's different geology on the surface. So there's darker black areas and there's lighter red areas. And then, even most interestingly, there's a really white patch at the bottom. And we know that that's actually a polar ice cap on Mars.
It's a tantalizing prospect, isn't it? Even through an amateur telescope, you can see these interesting features. And
Yeah.
just for fun, and because it's really cool, we've got the opposite view, haven't we? I think we've got a picture of so this is Earth viewed from Mars. Is that right?
Yeah, exactly. And it's really a perfect comparison because this is taken with, again, about an 8-inch telescope. And this one, it's not on the surface of Mars, but it's one of the satellites that orbits Mars. And it usually uses this telescope to point down at the surface and take really high detailed images of the surface of Mars. But just for a change, they pointed it back towards the Earth to get a different perspective. And here we see a really good comparison. This is what the Earth would look like if you were looking at it from an amateur telescope on Mars, if you could get there.
It's very cool, a Martian's eye view of the Earth, and yeah, we do see those similar features, and
Yeah,
that image of Mars that we saw earlier, that's basically what the first astronomers would have seen when they looked at Mars through their telescopes, which did lead to some interesting interpretations. What were some of our early ideas about the surface of Mars?
yeah. So those early astronomers were kind of limited by what they could do. They couldn't send spacecraft, obviously. This is a few hundred years ago. All they could do was every 2 years they could get a really good view with their telescopes and see what was happening on the surface of Mars. And they made some interpretations kind of based on what they thought the Earth would look like if you were looking at it from afar. So that image of the Earth we saw from Mars, a lot of the surfaces looks really dark actually, and that's how the oceans on Earth look from a distance. So it didn't seem like such a big leap for them to see the dark areas on Mars and say, well, maybe those are oceans on the surface of the planet. So when they came to map the surface, like this one by Schiaparelli, they mapped all the dark areas, and they were quite accurate with where they mapped them. But then they interpreted those dark areas as being mare, or oceans.
Exactly. So accurate, but the interpretation's slightly off. And we've got another very interesting example. I think this one is my favorite. This is Percival Lowell. What's going on here?
Yeah, it's not spiders on the end of their telescope. We don't think. But yeah, so this is kind of an example of using a little bit of information and taking the interpretation too far. And what he was drawing here was actually he thought that what we were seeing, the black lines on the surface of Mars, were actually canals being built by some intelligent civilization that lived there. So we know that that was incorrect now, but it just shows we have to use some caution when we only have a little bit of information on the subject. We can accurately describe it, but we don't necessarily want to make too many interpretations.
Absolutely. And advances in technology, they've allowed us to see the surface of Mars in more and more detail, which has led to some brilliant discoveries, but some disappointments as well. We've got one quite infamous example, I think, to show. Yep.
Yes, the now infamous face on Mars. And it really shows. I mean, both of these were taken by satellites that orbit Mars, but it really does show how far the technology has come. In the 70s, that was the best image of this feature that we could get, and it looks a lot like a giant face carved out of rock. But that was a lot of it was just the time that the picture was taken and the lighting and where the shadow was. And when we take pictures of it now, we can see that actually it's a pretty ordinary sort of hill. Um, not that that's boring, but not quite as exciting as someone carving a giant face.
Sadly not, sadly not. And of course, our technology has moved on immensely. We no longer rely just on telescopes. We sent many missions to Mars, even to the surface, and we've got
Mm.
rovers on the surface. Is that right?
Yeah, so there's two spacecraft that are active on the surface now. You've got Mars Curiosity, which is a really big rover. It's about the size of a small car. Opportunity, unfortunately, we might get to that later, but it was active up until about a year and a half ago. It came to the end of its mission. And there's even a new lander, InSight, and that landed also a couple years ago. So there's two robot missions on the surface currently. There have been many more in the past. And in orbit, there's quite a few satellites as well that are always taking more pictures.
And they're doing incredible work mapping the geology, looking at the atmosphere, all sorts of amazing things. So how many rovers do we currently have on the surface?
So yeah, it's only one rover on the surface. Technically, a rover has wheels and it can drive itself around. The other one, InSight, is we just call it a lander. So the type of science it's doing, we don't want it to be driving around. So it's set up some seismic equipment on the surface to detect really subtle vibrations in Mars. So we're looking for Mars quakes, basically. So for that, you don't want it to drive around. So we don't call it a rover, it's just a lander.
This image is absolutely brilliant. We should say for our viewers that this is an image that Zach has drawn himself. He's quite a talented artist, and one of our poor rovers is now asleep, isn't it?
Yes, it put in a really good long mission, but a couple of years ago, Opportunity, it just got too much dust on its solar panels and it couldn't charge its batteries anymore, and it stopped working. So this is kind of my small commemoration to it. Only two robots on the surface of Mars now.
But the population is soon to rise, isn't it? Because there are missions that have launched and are on their way.
Yeah, absolutely. So it kind of comes back to what I was talking about earlier about the way that Earth and Mars line up only every 2 years. So you only get it's and that time when the planets line up is the best time to launch missions to Mars. So any space agency that has a mission they want to do will all launch it at the same time. And this year, earlier in the summer, there were actually three missions launched. So NASA's launched one. That's the Perseverance rover. So it looks quite similar to Curiosity. It's actually going to have a little drone, like a little helicopter drone on its back. So hopefully that'll be the first thing to fly on Mars. Will be very exciting. But also the Chinese Space Agency and the United Arab Emirates have also sent spacecraft to Mars. So hopefully in a few months, the population will be going up.
That's fantastic. And will some of those missions be looking for signs of water?
Yeah, it's one of the main. It's often one of the main focuses of missions to Mars. The Perseverance rover in particular is going to be looking at an area where we're pretty sure that there was a lake in the past.
And that is the nitty gritty of our talk, isn't it? Because your work is involved in looking for signs of water on the surface of Mars. So, however, have our ideas about water on Mars kind of changed and evolved over time?
Yeah, so I mean, it's first worth saying that we see a lot of headlines about, oh, the scientists have found water on Mars, or we we think we found water on Mars. And the truth is, we actually know that there is water on Mars today, even. Um, but it's all frozen. So we can see it in the ice caps, and we think it's under the surface in a lot of places. So when we talk about is there water on Mars, we know there is water, but we're really wondering, is there liquid water somewhere on Mars? That's more interesting when it comes to searching for life.
Absolutely. So the water ice at the poles, that's permanent, is it?
Yeah, that's permanent. So unlike the polar ice caps on Earth, which they the water melts every year and falls again as snow somewhere else on the planet, the ice caps on Mars, the water actually generally stays put. But what you do get is the white that we see on the surface, the carbon dioxide ice, that gets smaller and larger, fluctuating with the seasons on Mars.
And have we found signs of ice anywhere other than the poles, anywhere else on the surface?
Yeah. So one of a lander that the Phoenix lander a few years ago had a little a shovel. It was able to dig into the soft surface of Mars, and immediately what it found right under the surface was a hard white material, and that was tested and found to be water ice. So we're not sure how prevalent this is across the surface of Mars, but it's probably true that there is a lot of water just frozen right under the surface of Mars. But we won't know until we send more missions to look.
Wow, and that really is just below the surface, isn't it?
Yeah. And one of the interesting things that this image shows as well is that even water ice has a really hard time existing on the surface because the pressure is so low. So these are actually two images of the same hole taken a few days apart. And in the little oval in the corner, you can see the image on the left was the first one taken, and they had actually dislodged a few little pieces of ice that fell into the hole. Now, the thing about Mars is it actually gets warm enough that ice melts on the surface, but the air pressure is so low that it can't turn into a liquid, so it just vaporizes and disappears. And that's what you see in the second image. So even if you
Right.
were to put a glass of water out on Mars today, it wouldn't actually stick around. The atmosphere is just too thin to support liquid water.
So there's no liquid water on the surface of Mars at the moment. But what about back in the past? Because you've been looking at science of water from way back, haven't you? So how do you go about doing that?
Yeah, so that's where the training in the geology of Earth comes in, because we see a lot of features on Earth, obviously, that were formed by water. So things like river valleys and shorelines, deltas, things like that. And what we do is we see similar features on the surface of Mars, so we interpret that they were probably formed by similar processes, meaning that there must have been water on the surface of Mars in the past.
And when we say in the past, how far back are we talking?
Yeah, it's a good point. It's not just last week. We're talking 3 to 4 billion years ago, generally, is when we think that there would have been a significant amount of water on Mars.
We've had a couple of questions from our viewers. I just want to drop in before we get into some of this imagery, because Ellen on Facebook was asking, do you get to do any field work here on Earth that is analogous to Mars?
Oh, that's a great question. So, yeah, there's a lot of places on Earth that, for various reasons, are very similar to the surface of Mars. So a lot of them are kind of dry deserts, or cold deserts as well. If you go to the Arctic regions, I've not been able to go to any of these personally myself yet. It's not really the focus of my PhD, but I would love to eventually. Maybe once I do some research, once I finish the PhD. But it's a great question. It's that is how a lot of the work on Mars gets done.
Mm. But your research involves looking at a lot of satellite imagery, doesn't it? And you've put together some great examples we're going to take a look at now. We've got a bit of a challenge for our viewers at home as well. We're going to have two images. One is of a geological feature on Mars, and the other is on Earth. We want you to see if you can guess which one is Martian and which one's on Earth. And for extra bonus points, you can guess what type of feature we're looking at as well. That would be fantastic. But let's take a look at the first image
Yeah,
now.
I mean, they're strikingly similar, right?
They
Um,
are definitely.
there's definitely a giveaway. I wonder how many people will get it, which one's Earth and which one's Mars. But
Yeah,
um, but yeah, the major thing to realize from this is they are very, very similar features. Should we tell them what it is?
absolutely.
Yeah, I think it's pretty recognizable as a river. Oh, and one of the things that really makes that recognizable is the way it meanders across the surface, these wide curves, and also the way you get all of these small tributaries kind of spreading out but focusing down, joining the main river and getting larger and larger. And it's really typical of what we see of rivers on Earth.
They are so similar. Now, which one's which? It's kind of obvious with all the craters, but the top one is Mars.
Yes, yeah, the top one's Mars in this instance. I tried to choose a red one for the bottom, but that is actually in the desert in Australia. So It's a good point about analogous environments, actually. There are a lot of places on Earth that look very similar to Mars, and deserts are definitely one of them.
Absolutely. So let's take a look at our next image. I think this one is a little bit too easy. I think I can definitely guess which one's Earth.
No points for guessing Earth on this
No
one.
points for that one.
Uh, as far as we know, there's no vegetation on Mars. There's definitely not oceans there. So this one's pretty obvious. But what it does show is the really similar features on either side. Again, starting from the top of the image, you have a valley that kind of winds its way down towards the bottom. And on the image of Earth, on the right there, you can clearly see that where the ocean is, the valley kind of stops being one major valley and fans out into a number of different small channels. And when this happens, the speed of the river slows down and it dumps all of the sediment that it's carrying. And we call this a delta. And it forms often when a valley reaches a standing body of water. And it's really similar what we see on the left of the image of Mars. You'd see this valley winding down and then forming this large fan-like feature at the bottom.
Absolutely, they are incredibly similar. We've got one more image, and this one is actually very tricky. I'm not sure if our viewers will guess which. Let's take a look. Yeah, when I first saw this, I really wasn't sure.
No, yeah, this one's much more tricky. There's no craters in there to give it away, is there?
Absolutely, and very similar looking surfaces, and yeah, color that you might expect on Mars. But the feature themselves is quite tricky as well. What exactly are we looking at?
Yeah, this one's a bit more subtle than the first two images we looked at. So the image at the top shows it a little bit better, and what we're actually looking at is the kind of concentric lines that go around the surface, concentric parallel lines.
Mm.
And what these are is there used to be a lake standing in this area, and and eventually the lake started to dry up. And as it dried up, it would form a new little shelf where the waves were breaking on the shore. And then the lake would shrink a little bit and cause a new little shelf all the way around the lake. So what this is, we're looking at a series of small steps, each one of them showing where the edge of the lake used to be a very long time ago.
Wow, that is incredible. And which one's which one's Earth and which one's Mars?
So yeah, the top image is the Earth in this case, and that's an area in Utah in America where there used to be a lake. There isn't anymore. And the bottom one is Mars, and it's a bit harder to see on Mars. But again, we're looking at something that's a few billion years old. So you can see just on the kind of the right side of that image, you can see some of those parallel lines, and these are possible shorelines on Mars.
Okay. It's absolutely fascinating. It really is. So we've got rivers and we've got signs of lakes as well. What about oceans? Were there potentially oceans, and how big would they have been?
Yeah, oceans is a bit more problematic because we can say that water was flowing across the surface or there was a limited lake somewhere, but to have an entire ocean of water, it requires so much more water than we see on Mars today that it puts the theory in doubt a little bit. But when we look at topographic maps of Mars, like this one, the red areas being high and the blue areas being low, we can see that most of the northern part of the planet is actually really low and flat. Similar, some people think, to what the floor of an ocean would look like if you drained away all the water. And add to this that people have spotted shorelines around the edge, also possible deltas, and most importantly, a lot of the valleys on Mars all end along this edge as well. So it all kind of points to the possibility that there was a body of water standing in the northern hemisphere of Mars a very long time ago.
Wow, we've got an artist's impression of what that might have looked like. That's potentially quite a lot of water, seemingly.
Exactly, and this is kind of one of the issues with this theory is we geologists we say, well, we see all these features that suggest there might have been water there, but then we have to kind of square that with other scientists who study the climate, the past climate of Mars and the atmosphere. And a lot of that other research points to there never having been, well, for one, a warm enough climate for there to be an ocean on Mars, but also just not enough water in the past. So it's how science works, though, where it's a bit of a back and forth. So we'll get to the right answer eventually.
Now we've had some lovely questions from our viewers, so I just want to get through some of those. So Timothy, aged 8, on YouTube, has asked, would the water on Mars have been salty, possibly like the oceans here?
That's a really great question. So, simple answer is we just don't know. There's a few things. So the oceans on Earth are salty because minerals are weathered out of the rocks very slowly, and eventually that builds up in the ocean, where water is only flowing into and evaporating out of. So you don't get so all the salts build up in the water there. That's why lakes are freshwater, because they're still draining out into the ocean. So they never get that buildup of minerals in them. So we don't know. I mean, on Mars, it could be that the oceans were not there for long enough to become really salty, but some of the evidence points to the oceans needing to be salty to stay liquid in a really cold climate. But the short answer, as so many things with Mars, is we just don't know yet.
And that's okay. That's absolutely fine. Now,
plenty of work to do in the future.
Exactly. We've had a question in from Benjamin on Facebook, and I thought this one might come up actually. He's asking, have you seen the paper just released on subglacial water bodies in the Martian South Pole, detected by Mars Express? Do you think this is stronger evidence for liquid water on Mars, so subsurface water?
Yeah, I mean what makes that particularly exciting is the work that I'm doing. Again, we said that's 3 to 4 billion years ago, but these lakes underneath the ice caps, that's talking about presently on Mars. So that makes it very exciting in terms of the possibility that if there's liquid water there, maybe there would be life there currently even. But there are some caveats with this. The evidence seems very good that they are detecting some liquid water under the surface, but it is under a few kilometers thick of ice cap. So it'd be very dark and very cold underneath. And also, it's probably not like a lake that most people would consider. There's a chance that they're seeing water underneath these ice caps, but it's probably only a meter or so thick. So, and it might be really muddy. So it might be liquid water, but it's probably, you don't want to imagine it in terms of a fishbowl with lots of clear water and creatures swimming around in it. Probably more like a bit of a sludge underneath. Still, very exciting nonetheless.
Absolutely. And this links quite nicely to a question from one of our regular viewers, Noah, age 6, who was asking, how thick is the ice on Mars?
Yeah, so as I mentioned, at the polar ice caps, it's kilometers thick. So very, very thick buildups of ice. As for other places on the planet, we're not really sure. It's really difficult without actually drilling into the surface. So everything we know about how thick the ice caps are at the poles of the planet, we know that these are thick based on radar readings of the poles. But on other parts of the planet, we can't really tell. So until we get a rover there that can drill into the surface, we probably won't know. Again, more work for NOAA to do in the future, maybe.
Exactly. That's science for you. It's always interesting questions. Now, Zach, your current research is looking specifically at ancient lakes on Mars. So tell us a little bit about that particular project.
Yeah, so the fact that there's lakes, that there used to be lakes on Mars, isn't new research. What I'm trying to do is look at a very particular area where no one had seen any lakes in the past. And I've identified where it looks like there were standing bodies of water. And I'm going into more detail, trying to nail down how long these lakes would have been active and how they changed over time. And what makes this really interesting is there's about 6 or 7 lakes linked up into a chain. where the highest lake would have filled up and then drained out to fill the next one down, and the next, and the next, and the next. A lot like you see lake chains here on Earth.
Right, I was going to ask, is this similar to processes we see on the Earth today?
Yeah, it's quite similar. I mean, the lakes that I'm looking at are on a smaller scale, but big lake systems on Earth, like the Great Lakes in North America or the Great Lake system in the Rift Valley in Africa, do something similar. So you have higher lakes with valleys in between, feeding the next and the next.
I love these images as well. I love the fact that you've added the color, because it really brings it home. It can be really difficult, especially to the non-geologist's eyes, to actually see these features. So this is fantastic.
Yeah, absolutely. I mean, we spend a lot of time looking at these images in great detail because a lot of the time the features don't jump out at you. It takes a lot of time looking at them carefully before we're confident enough to add our own interpretations to them.
Mm. And if we think there were potentially fairly large bodies of water on the surface of Mars at some time in the
Mhm.
past, could there have been something like a water cycle? Could there have been rain on Mars in the past?
Yeah, that's a really great question because again, we're not really sure. So uh, people's immediate thought, probably with seeing lakes and rivers and things, would be to imagine that, oh well, there must have been rain falling on the surface that then accumulated and flowed across the surface to fill these features. But it might not actually be so straightforward. It could be that some of these features are formed by groundwater upwelling. So you had a lot of frozen water under the ground at some point that was released very quickly or very slowly, or that you had large ice caps and glaciers somewhere in the highlands, and just the fact of these melting formed a lot of the lakes and deltas and rivers that we see. So
Mm.
you don't necessarily need to have an active water cycle like we do on Earth to get these features. And that's one of the things that we'd really like to find out, based on exactly how these features formed and how long they were around. That might help tell us whether there was rain and precipitation as we know on Earth, or whether it was something different.
Mm. And we had a question in from Greg on Facebook, asking what sort of age for the lakes that you're looking at? Roughly when would they have held water? Do you know?
This I'm still trying to work that out. So roughly, again, this is probably an unsatisfying answer, but around 3.5 billion years ago, which is not
A
very
long
specific.
time ago.
Yes, a very long time ago, kind of fitting with that period of Mars, uh, where we think oceans and a lot of these things
Mm,
were active. Um,
mm,
there's some evidence on other parts of the planet that some lakes might have been active much more recently, so within the last billion years, but it's really hard to tell. And these were, if that was the case, then they would have been very short-lived features, not something that was there for a long time.
mm. A couple more questions from our viewers that I just want to get through. Oh, Greg again on Facebook. I'm not sure if
Sure,
you'll be able to answer this one actually, but we'll give it a try. He's
sure.
said he hasn't heard anything about InSight's drill recently. Has it failed?
Ah, yeah. So for people who don't know, the InSight rover that we were talking about that's doing seismic measuring underneath the surface, it also had a probe that was going to drill into the surface. Uh, but basically, the surface was a different texture than they thought it would be, because a lot of these things we just don't know until the rover actually or lander actually gets there. You can make a lot of guesses from orbit, but until it gets there, we're not really sure. So it's not worked as it should. It was meant to kind of insert itself about 5 to 8 meters down underneath the surface, and it's only got a few inches now. So as far as I know, they're still trying, but it is not working properly.
Oh,
but
that's a shame.
this is the thing with missions to Mars. Each one we find out something new, and then try to prepare for the next missions after that.
It's quite a technical feat, and it's sadly not as though you can just pop to Mars to do your field work directly.
Unfortunately, not. My PhD funding doesn't have that in it yet, but we'll see what we can do.
Maybe one day. Now, earlier we had a great question on YouTube, which we briefly sort of touched on a little bit earlier. But the question is finding water on Mars a sign that there might be life there or have been life there at some point?
Yeah, it's a fair question because so many of the missions that are sent to Mars go to places where we think there was water in the past for that very purpose, to see if there are signs that life existed in the past as well. And the big thing that I think is worth mentioning is that even though all life on Earth requires water to survive, it doesn't necessarily work the other way around. It might not be that wherever there's water, there's definitely life. Earth may be a bit of a rare case in the universe that all the conditions were perfect and life formed. But on Mars, it could be that for millions of years there was a warm climate and water on the surface, but it doesn't necessarily mean that there was definitely life there at one point. So it's our best guess for places to look. We look for places that were wet in the past, but it doesn't mean that we'll definitely find life there.
Mm. And of course, a lot of our current missions are looking for signs of life. But when we say signs of life, what kind of life are we talking about? It's not complex life, is it?
No. So a lot of this is basically coming down to how we know what we know about how life evolved on Earth. So Earth and Mars both formed around the same time, and around 4.5 billion years ago. And for both of them, we think they had lots of liquid water on their surface around that time in the first billion years or so. So what we know about Earth is life formed quite quickly after that, but then it took billions of years more for complex life to form. So if the window on Mars, where there was a perfect climate for life and enough water and everything was right, if that window only existed for even a few 100,000 years, even a billion years, I think that that's probably, from what we know on Earth, that might not be long enough for complex life to form. So when we talk about looking for life on Mars or past life, we're probably not going to find something that would look like a fossil. We're more looking for chemical signs that life existed in the past, something bacterial or algal, something very simple.
Mhm. We had another lovely question on Facebook. This time, Graham was asking, related to water in the past, probably.
Hmm.
Would the moons of Mars cause tidal activity? Which is a very
Ah,
interesting question.
yeah, it's very interesting. So the short answer is probably not much. The moons of Mars are very small compared to the moons of the Earth. Um, even though the moons on of Mars are much closer than our moon, they're so small. They look a lot like asteroids. Actually, they're not even spherical. Um, and from what we understand of it, there wouldn't be any tidal forces from the moons. Although on Earth, a lot of the tidal forces moving the oceans around, a lot of that force comes from the sun, not just the moon. So you might get some tidal movement from the sun, but probably not much. It'd be very minor.
Great question there, Graham.
Yeah,
Really interesting.
it's
Now,
fascinating. It really puts you in the position of being there. I think when you try to
yeah.
imagine what these different processes would be like on a completely different planet.
Absolutely. Now, we've been talking about water at the surface of Mars. The burning question is, if there was water in the past, where did it all go? How did
Hmm.
Mars become the desolate planet that we know today?
Yeah, it's a great question. So the thing with from what we understand, most of it comes down to the small size of Mars. So we don't really think of it here on Earth generally, but what's holding the atmosphere down on Earth is the gravity of the planet. So we don't think about the atmosphere around us as weighing very much, but it weighs enough that the planet does pull it down. And that's why we have a nice thick atmosphere here on the surface. So Mars being much smaller than Earth, it has less of a gravitational hold on its atmosphere. But also, we believe that if Mars ever had a magnetic field in the past, it probably stopped operating a very, very long time ago. And having a magnetic field is one of the things that protects an atmosphere from solar radiation. And without that protection and with a lower gravity, we think that eventually the atmosphere of Mars was slowly stripped away over billions of years. And once the atmosphere got thinner, we get to the situation where it can't hold as much heat and water starts to evaporate away as well. And it ends up as the cold desert that it is today.
It's quite unnerving, isn't it? So could the same thing happen on our Earth? Presumably not.
I wouldn't start to panic just yet.
Good.
From what from what I understand, we've still got probably a couple billion years left at least. Magnetic field on Earth is not my specialty, but don't put it on your calendar yet. Our magnetic field is probably okay.
Good to know. Good to know. We're sadly coming up to the end of our talk, I'm afraid. But Zach, I did have one more question for you.
Sure.
If you could go to Mars and do field work, would you go?
Oh, I would love to go. Yes, I would absolutely love to. Although it's quite a long return trip. Well, the way we think about it now, again, how the planets line up, it's about 2.5 years for a return journey. So I don't know. I mean, my wife probably doesn't want me to go, but I'd have to seriously consider it. But what an opportunity!
Absolutely, a wonderful opportunity. Well, Zach, we are sadly at the end of our talk. It's been absolutely brilliant finding out all about Mars and about your research, which is just fascinating. Hopefully, we can have you back on Nature Live again in the future to update us on your work, and we'll perhaps hear about some of the exciting missions that have landed as well. But thank you again. It's been fantastic to speak to you. But we'll say goodbye to you for now.
Great. Thanks for having me.
And thank you to you, our viewers. I hope that you enjoyed that as much as I did. And thank you for all of your brilliant questions. We're going to be back on Friday at 10:30, and we're here every Tuesday at 12 as well. So do join us again. Keep an eye on our social media feeds and our websites to find out what fascinating topics are coming up. We hope to see you all again soon. But for now, I will say goodbye. Have a great day and see you soon. Thank you.